Tuesday or Wednesday. I'm obviously gone and in Colombia, but I wanted to share some good content with you today, and you can follow along as you need to, and then go ahead and we're just gonna finish up that work and submit it online to the portal. So first announcement, your next quiz number 6 is gonna be on the mole, right? And that will be on the 27th or the 28th, depending on if you're in first and second, you're on the 27th, fourth period, you're on the 28th. Next announcement, you need to upload your molar ratios homework and limiting reactant simulation lab to the portal right now if you have not done so yet, right? You have to do that to receive credit. Third announcement, don't forget to upload your homework today to the portal when you complete it. You should be able to complete the entire worksheet in class and have no extra work outside of class, okay? If you get stuck today, please ask a neighbor, right? Do not do this alone. Or go ahead and see the topic boards on my Dub for some extra videos that can help you as you work through these types of problems. Okay, so let's get started talking about what we're learning about right now. So first up, we just finished this limiting reactant simulation lab, right? And this was kind of the idea that if you have some of a variety of things and you're trying to make an end product, what determines how much you can make, right? The thing that you have a lot of or the thing that you have a little of. You could think about this like if you're gonna go home and bake some cupcakes, right? And you only have 2 eggs, but you have pounds and pounds of flour, right? Flour is not gonna be the thing that determines how many you can make. It's the thing that you have less of. So we're gonna work through one problem together that's a limiting reactant problem, and then you'll have your homework to work through by yourself. So pull out your notebooks. It's time to take some notes. Okay, so we're gonna title these notes Limiting Reactant Notes. Okay, and together what we're gonna do is a single problem. So our example that we're looking at today is if you start with 5.25 grams of potassium nitrate and 2.30 grams of sodium fluoride, how many grams of potassium fluoride should you produce? Okay, so let's go ahead and take a look at what our starting values are. Okay, we're given 2 starting values. We're given a value of potassium nitrate. We're given a value of sodium fluoride. And our end goal is to figure out how many grams of potassium fluoride we make. So we need to write out a chemical equation here, right? So we are combining potassium nitrate with sodium fluoride. And we know that we're producing potassium fluoride, so this is a double replacement reaction, which means the other thing that we make is sodium nitrate. Okay, so now that we have an equation, we need to balance that. The nice thing is this one's pretty easy. We have 1 potassium, 1 potassium, 1 nitrate, 1 nitrate, 1 sodium, 1 sodium, 1 fluorine, 1 fluorine. So this is a 1, 1, 1, 1 reaction. Okay, so the way that a limiting reactant problem goes, we identified what we know and what our unknown is. We balance that chemical equation. So now what we're gonna do is we're gonna find an answer for each of our starting values. Now, we're given 2 values in grams of our reactants, right? If we look back at our mole map, that would be like being given a mass of A. And we're trying to find a mass of B, right? So we're gonna need to use a molar mass to get to moles. We're gonna have to use that molar ratio with coefficients from our chemical equation, and then another molar mass to find our final answer of how many grams of potassium fluoride can we produce. So let's look at our first value that we're given. We get a starting value of 5.25 grams of potassium nitrate. Now, it is really important that we write out our formulas, right? We've been talking about this a lot in class, but now that we're working with multiple chemicals in each one, it's important that we have all that information there. So, if we go ahead and we use our periodic table, we're going to need to add up, to go from grams to moles, our molar mass. So why don't you take a second to do that? Find the molar mass of potassium nitrate. Okay, hopefully, like me, you found that our mass of potassium nitrate is 101.11 grams of potassium nitrate, and that's in 1 mole of potassium nitrate. Now that I'm in moles, right, I completed that first step on my mole map, which means my second step is my molar ratio using coefficients from my chemical equation. So let's take a look at this. My coefficient that is in front of potassium nitrate, that's a 1. That's a 1, right? So that means I have 1 mole of potassium nitrate, and I'm going to potassium fluoride, right? KF. And there's a 1 in front of KF. So there's 1 mole of potassium fluoride. Okay? Now that I made it to moles, I then have one more step to go from moles back to mass. So I need to calculate another mass. In 1 mole of KF, I need to figure out how many grams of KF there are. So why don't you add up another molar mass? What is our mass of potassium fluoride? Hopefully you found that to be 58.10 grams. And now we're going to do some math, right? We're going to remember that we multiply across the top and divide by what's on the bottom. So we do 5.25 times 1 times 1 times 58.10, and we divide that by 101.11 and 1 and 1. And we should get 3.01676 grams of KF, right? We reached our final desired unit, right? We made it to that grams of KF like it asked us for in the problem. Okay, this leaves us with one last thing that we need to do. Sig figs. So if we look at our starting value, right? Our starting value has 1, 2, 3 sig figs. So we get to keep 1, 2, 3 sig figs, which means this turns into 3.02 grams of KF. Okay, that's like a normal problem that we've done up till now. But we have another starting value, right? So we now have to solve this a second time. Should be a little faster, right? We already have some things that we know. So now we're going to solve it with 2.30 grams of sodium fluoride as our starting value. So go ahead and add up what is our molar mass of sodium fluoride. Hopefully you got 41.99 grams of sodium fluoride is equal to 1 mole of sodium fluoride. This leaves us with another molar ratio, but here we are looking at our sodium fluoride. So we see that there is 1 mole of sodium fluoride for every 1 mole of potassium fluoride. And then we go 1 mole of potassium fluoride, and we already calculated up here that its molar mass is 58.10 grams of potassium fluoride. That gets us to our desired units, right? That's answering our question. So let's plug this one into our calculator. We do 2.30 times 1 times 1 times 58.10 divided by 41.99 divided by 1 divided by 1. And we get that this answer is 3.18242 grams of potassium fluoride. Now, let's sig fig that as well. We get 3 sig figs to start. We get 1, 2, 3. So this answer is 3.18 grams of potassium fluoride. So now our question is, which one should we pick? Do we pick the bigger answer or the smaller answer? So to figure this out, let's think back. If I can only make 2 cakes with the number of eggs that I have, even though I could make 5 cakes with the amount of flour I have, I can still only make 2 cakes in the end, right? I have to pick the smaller amount. Same thing is true here. Our lesser value is always the final answer. So if these are both our answers, right, we say that this one is the lesser value, right? And this one is our greater value. And our final answer will always be the smaller one. So we say final answer is 3.02 grams of KF. That is our final answer. Circle it, star it, put a box around it. Okay, so one other question that you could be asked at this point is, which one of these things is our limiting reactant? And which one of these things is our excess reactant? Now, limiting is the thing that limits it, right? So if we look back at what gave us our lesser value, it was potassium nitrate. So that means our limiting reactant here is potassium nitrate, which means which one did we end up with excess of? Sodium fluoride. So we have now worked through one whole limiting reactant problem, right? There is a worksheet that should be up front that is called your limiting reactant homework, and it looks like this, right? There are 5 questions. Question 5 has a lot of parts to it. All the answers are on that back page, which means if you upload just those answers online, that will not be worth credit. So please work with a neighbor on this, work by yourself, do whatever you need to do, and please see on my AW if you have questions or get stuck. There are extra videos to help. I will see you guys next class. Bye.